Good morning, Geometry Honor students. So Mr. Chen again. So today I would like to talk about the continuation of Unit 11. So 11.7, 11.8 from the Big Idea Geometry. So the surface area of circular solid. So this one's part 2 of those two sections. Objective for the lesson today. So find the surface area of circular solid. So the formula for the surface area of a cylinder, it's the lateral area plus 2 times the area of the base. So the way to find out the lateral area of a cylinder, it's 2 pi r, which is the circumference of the circle, the circular base, times the height. So once you find the circumference of the circle, multiplied by the height, you'll generate the lateral area. And then plus 2 pi r squared, because that we do have two circular bases. So one on the top, one down the bottom. Okay, so once we combine them, so we'll end up with the surface area. And then the surface area of a conical a cone, so then that would be considered lateral area plus the area of the base. So the lateral area of a cone, which is 2 pi, it's a pi RL. Okay, so pi r times L. So L, which is the slant height. Okay, so we talked about that for the previous section already. So it's the slant height. And then plus pi r squared, the area of the base. And now let's see what else that we have for those formula. And for the sphere, the way to find out the surface area of a sphere, it's 4 pi r squared. The way to get the volume, it's considered 4/3 pi r cubed. Okay, so those are the formulas that you need to recognize. And then for the hemisphere, so hemisphere, the way to find out the surface area, it's a lateral area plus the area of the base. So 2 pi r squared to get the lateral area, and then pi r squared, the area of the base. So once you combine them, so it's 3 pi r squared. And the way to find out the volume for the hemisphere, it's just 1/2 times 4/3 pi r cubed. So 2 goes into 4 twice, so this one is just 2/3 pi r cubed to get a volume of the hemisphere. Okay, so now let's see what we got. So let's take a look at the example. Find the total area of the solid. So this one is being generated by the lateral area of the cone, the lateral area of the cylinder. So let's say the lateral area, so let's say it's L. So we do have L1, L2, and then L3. So the lateral area of the cone, the lateral area of the cylinder, plus the lateral area of the hemisphere. Okay, so the way to do it, so start it off with pi RL to get L1. So pi r, so pi times radius, 5, L, the slant height, 13. So 13 times 5, so we do have 65 pi. So the unit for that, square centimeter. And then to get L2, so this one is a cylinder. The way to find out the lateral area of the cylinder, so 2 pi r times h, so which is 2 pi times the radius, 5, times h, 10. So 2 times 5, 10, 10 times 10, 100, so it's 100 pi square centimeters. And then to get L3, so it's a hemisphere, so the way to do it, so this one, it's considered 3 pi r squared. Without the base, so just 2 pi r squared. Because again, those circular bases, so they're considered empty, they're not solid, so they're empty. And this one, 2 pi times radius, quantity square, so 5 square. So 25 times 2, 75 pi. And then to get the total area, we just want to combine them all together. So 65 pi plus 100 pi plus 75 pi. So 65 plus 75, which is what, 140? So 240 pi. And it's square centimeters with the final unit. Okay, so now let's see what else that we have. Find the surface area of a frustum. The frustum is just the lantern shape. So in order to get the surface area, so we need to find out the area of those bases, the small circle, the big circle. So to get the area of the base, so we do have pi times r squared plus pi times capital R squared. So this one is just basically pi. Take out that pi as the greatest common factor, so r squared plus capital R squared. So we got pi. Radius, small radius is 5, 5 squared. Bigger radius, which is 10 squared. r squared, 10 squared. So 25 plus 100, so it's 125 pi, or pi times 125, which is 125 pi. And the unit, square meters. Now the thing is that, what about the lateral area? How do we get the lateral area of the frustum? So the way to do it, so without the formula, so we can always set up that the imaginary small cone. Okay, because once you set up the cone here, so that'll be a small cone. So the way to do it, we can find the area of the whole cone, the big cone, plus the imaginary cone here. So, and then subtract the lateral area of the small cone. Okay, so to get the lateral area of the frustum, so we want to find out the lateral area of the big cone. So pi capital R times L. Okay, so let's say this one L here is L1. Okay, so the entire slant height. And then minus pi times small radius. And then this one, let's say L2. Okay, L2. So the way to do it, okay, so let's see. Using proportionality, okay, so we do know that L1 is considered L2 plus 6. So L2 plus 6 over the bigger radius, over 10. So this one is the same as the ratio of the slender height of the smaller cone. So L2 over the smaller radius, the shorter radius of the smaller cone. So 5. And then using proportionality, so we do know that this one is 10 times L2 equals 5 times L2 plus 30. So solve for L2, so 10 L2 minus 5 L2, then that'll be 5 L2 equals 30. So L2, then that'll be 6. So once we get L2, we can get L1. So L1, then that'll be 6 plus 6, okay, which is 12. So pi times the bigger radius, so 10 times 12. Okay, so L1, then that'll be 12. Minus pi times smaller radius, which is 5, times L2. So L2, which is 6. And then, so 120 pi minus 30 pi, then that'll be 90 pi. Okay, so we got the area of those bases, and we got the lateral area of the lantern, so we just combine them together. So the total area, or the surface area, which is 90 pi plus 125 pi. Combine them, so then that would be considered 215 pi. 5 plus 0, 5, 9 plus 2, 11, 1 plus 1, 2, so 215 pi. And the unit, square meters. Okay, so now let's see what else that we have. Find the total area of the cylindrical tank. Okay, so this one, inner radius, that's 3. And the distance from the edge of the smaller circular base here to this outer base here, so then that would be considered 2 inches. So the outer radius, then that would be considered 3 plus 2. Then that would be 5 inches for the outer radius. So smaller radius, inner radius, outer radius, the height of those cylinders. So again, imagine this one is like a paper towel or like a toilet paper. So the way to find out the total area, so that means we need to find out the area of this upper shaded region, the circular base, the bottom part right here, and also the lateral area of the whole cylinder, the outer cylinder, and then also the lateral area of the inner cylinder. Okay, so the way to do it, so let's just set up 4-step right here. So let's find out the lateral area of the outer radius, the outer cylinder. So then that would be considered 2 pi r times, 2 pi times capital R times h. So 2 pi times 5 times h, which is 6. So then that'll be 60 pi square inches. And then get the lateral area of the inner cylinder. Okay, this one is the outer cylinder. And then the inner cylinder. Similar, so it's 2 pi times little r times h. So then that'll be 2 pi times the inner radius, which is what, 3 inches, times the height, it's the same height, 6. So 2 times 3, 6, 6 times 6, 36. So 36 pi square inches. And then after that, we want to find out and the area of the shaded region bounded by the inner base and the outer base, the circular bases right here. Okay, so the way to do it, again, the way to find out the area, so it's pi times capital R square minus pi little r square, and then the whole quantity times 2, because we got the upper base, the lower base. So 2 times pi times outer radius again, which is 5, inner radius 3. So 25 pi minus 9 pi, then that would be considered 16 pi. Okay, let's just show all the work here. So it's 2 times 16 pi. And this one turns out to be 32 pi. And the unit, again, square inches. So once we get those lateral area, the outer cylinder, the inner cylinder, and also the area of the bases, we just want to combine all those 3 units together. So the total, okay, so let me get some space right here. Oops. Okay, so the total area, okay, I'll be using all those kind of highlighter. Okay, let's just make this one smaller. Okay, so the total area, this one's too light. Okay, let me change that. Okay, so the total area, so then that is what, 60 pi plus 36 pi plus 32 pi. So basically just combined all those coefficients together. So this one 60 plus 36, 96, 96 plus 32, which is 128 pi. And the unit, square inches. So that'll be the total area of this bounded shaded region, kind of like a toilet paper or the paper towel. Okay, so that's it. So any questions that you have, so please either rewind or fast forward back to the part of the previous content, the formulas, things that you need to recognize, surface area, lateral area, okay, of all those circular shape. Okay, so thank you for watching it once again. So I'll see you guys next time.